Hi guys, it's Ms. Myers again. We will be spending another week on line graphs. They're very important for the science ACT. Um, if you have not watched the previous week, week 5 on line graphs, that might be a good place to start. If you did watch that week, this week we'll be doing 2 more practice passages with line graphs and answer explanations. To access those practice passages, click on the link in the video description and then open the Jamboard, and there are 2 practice passages for you to watch and complete. You'll have 5 minutes to do each practice passage. Again, the link is in the description. To practice passage number 2, I'll give you 5 minutes, work on practice passage 2, and then we'll check our answers. All right, that's 5 minutes up for practice passage number 2. If you would like to check your answers, I have an answer document in that same folder with the Jamboard that has an explanation typed out for every single answer. Feel free to pause the video now and check your answers with the answer explanations. We're going to go over a couple of those that have to do with line graphs on practice passage number 2. All right, let's look at this passage. Okay, this one's interesting because we have 3 line graphs, lots of line graphs in this one. And you can see they use different symbols for each line because again, ACT is printed in black and white, so they have to use symbols to tell the difference between lines. All right, let's find some ones that have to do with figure 1, this first line graph. Okay, 34 is asking about experiment 2, so that's going to be the second figure. 35 is asking about figure 1, so let's look at 35. All right, based on figure 1, if a sample from trial 3, okay, trial 3, so that will be this black circle line, had been analyzed at 95 minutes, right? So we're looking at 95 minutes, which is off the chart. Sometimes they ask you kind of to predict where the line's going. The percentage of chromium remaining in the solution would most likely have been. So most likely have been, that means that we're going to have to predict. Okay. So let's look at that line. We're looking at that dark circle line, and we're predicting at 95 minutes, what will it be? Okay. For these prediction ones, it's pretty easy. Just got to kind of look at how the line's going. Line is decreasing, and you can see about where the slope is going. It will keep going down at 95. It'll probably be somewhere around here. Okay. If we look over on our side here, somewhere around there, let's compare this to our answer choices. Our answer choices are less than 5%, between 5 and 10, 10 and 15, and greater than 15. All right, we can immediately eliminate almost all these answers. We know it's going down. It was already at about 5% at 90 minutes, and it's still going down. So it's going to have to be less than 5%. It's still decreasing, and it'll have to still be going down. All right, let's see if we see any other ones from figure 1. Number 36 asks about experiment 1. So experiment 1, the results will be in figure 1. Let's do number 36. According to the results of experiment 1, as the pH increased from trial to trial, so yeah, pH went up with each trial, the time needed to remove chromium from the solution, increase, decrease. All right, let's see. So as pH went up, the starred one had the highest pH. Did it take longer or shorter to get rid of the chromium? You can see here in trial 1, this white circle, we got rid of it pretty quick. It only took 10 minutes to get rid of the chromium. In trial 4, with the higher pH, it still hadn't gotten rid of it. We still had a little bit left at 90 minutes. So it looks like as pH goes up, the time needed to get rid of the chromium also goes up. So number 36 should be F, increased only. All right, let's see if we find any other ones that go with this. 37 is asking about all of them, so you'd save 37 for last. 38 is asking, that's just a chemistry question. This one has nothing to do with the graphs. 39 asks about experiment 1. All right, let's do 39. 39, how many of the trials in experiment 1 were at an acidic pH? All right, I like this question. For the science ACT, you have to know very, very little science. There's not much background info you need to know. Most of this is just reading graphs. This one, you do need to know what are acids, what pHs are acidic. Okay, so this is just one background knowledge to know. For pH, you should have learned this in chemistry, 7 is neutral. Any number less than 7 is an acid. Any number greater than 7 is a base. Okay, so how many of them were acids? How many of them were less than 7? 1 was 1, 2 was 2, 3 was 3, 4 was 4. These are all less than 7. So these are all acidic pHs. So all 4, okay? So our answer is either C or D. Let's look at why they said these. C, because any pH less than 7 is basic. That's all right. D, any pH less than 7 is acidic. Yep, that's right. So our answer is D for number 39. Okay, looks like 40 asked about figure 3, so we've done all of our experiment 1 questions. Now let's look at our experiment 2 questions. I'll use a different color. I'll use yellow. Okay, which ones have to do with figure 2, experiment 2? Looks like number 34 does. Based on experiment 2, as temperature increased from 30 to 50, the time needed to remove all the chromium. So basically, this is kind of the same question as number 36, just changed the thing that they were the independent variable. All right, so as temperature went up, so as we go from this trial to this trial to this trial, did it take longer or shorter to get rid of the chromium? Okay, let's look at 50 degrees, the triangle. Looks like at 50 degrees, they got rid of the chromium pretty quickly. When it was colder, like at 30 degrees, it took longer to get rid of. Okay, so as the temperature increased, it looks like we decreased the amount of time that was needed. Yep, so you see here, it was warmest in trial 7, the triangle line, and that got rid of the chromium the fastest. In the trial 5, when it was colder, 30 degrees, it took longer to get rid of the chromium. The 34 should be F. All right, let's see if there are any other questions to ask about figure 2. 37 asks about all of them, so it's not going to be 37 yet. 38 is chemistry, and 40 is asking about figure 3. Okay, so you kind of get a choice at this point which one you would do next. You can do the chemistry one now or save it for the end. This one asks about all 3, so maybe we do this one now since we're at the end. All right, I'll use a different color since it's asking about all 3. How many trials in experiments 1 through 3 did the percentage remaining reach 0 in less than 1 hour? All right, 1 hour is 60 minutes. And how many of them did we get to 0 in less than an hour? Let's add them all up for all 3. They're asking about all 3 here. All right, first one, at 60 minutes, 1 hour, 2 of them reached 0. So we've got 2. Okay. All right, in our second one, this is in 10 minutes. By 10 minutes, all of them had reached 0. So that's 1, 2, 3. So we're going to add 3. All right, and then in our last trial, let's see, this is 40 minutes, so that's less than an hour. 1, 2, 3, 4. All of them also reached 0. So now we just have to add these up to get how many total trials reach 0 in less than an hour. 2 plus 3 plus 4 is 9. So answer 37 should be C. All right, I won't do these last 2 because they don't have to do with the graphs, but the answers are explained in the answer key document if you want to check those. We have one more practice I'd like you to do. Practice passage number 3. I'll give you 5 minutes to do it, and then we'll check answers one more time. Good luck. All right, that's 5 minutes for your practice passage number 3. Reminder, if you want to see the answers with explanations, there's an answer key document in the folder that's linked in the video description. Let's go through a couple of these from practice passage number 3. All right, zoom in. Let's find some that go with figure 2. So I like this line graph as practice because it's really not a tough line graph. It's just weird because it's like flipped kind of vertically. So ACT likes to do things like that. They like to put things in weird positions and stuff to kind of throw you off. Just pay attention to the axes. So again, here we're looking at CO2 content of the soil gas, and we're looking at depth. Okay, so basically, how does the CO2 change the deeper we go? So it kind of makes sense for them to put the graph on its side like this because depth as you go down into the ground increases. All right, let's find some that go with figure 2. 28, nope, that's figure 3. 29, nope, that's asking about the picture. 30, nope. 31, nope. 32 is asking about figure 3. 33, finally a question that asks about figure 2. All right, let's do it. And again, notice I skipped the whole reading the passage. That's a waste of time. I don't have to understand this experiment at all. I just have to be able to read the graphs, right? Don't waste your time, go straight to the questions. All right, number 33. Suppose that at each of the 5 locations, a diffusion well had been positioned at a depth of 145 centimeters. All right, so we're looking at 145 centimeters right here in the graph. Okay, so we'll have to predict a little bit because our last data point is at 140. Okay, based on figure 2, on November 23rd, November 23rd will be that black circle line. So we're looking here at this line. Okay. On November 23rd, the average CO2 content of the soil gas at that depth would most likely have been what? Okay, so we have to predict where is that black circle line going to be right here. Okay, we can see it's decreasing. We can see it's moving along here. Let's find which one of these answer choices fits best with this data. I think it's going to be a little bit greater than 0.4, right? Because it's still moving along there. So let's find one that looks like that. Letter D looks like that, a little bit greater than 0.4. So 33 should be D. Yep, that is correct. All right, let's see if we find any other ones for figure 2. Nope, that's the only one about figure 2. All right, now let's look if we can find any for figure 3. I will switch colors. Let's use yellow. Figure 3. All right, 28 asks about figure 3. According to figure 3, at what depth were the average water content values for the 4 dates closest in value? Okay. Again, pay attention to your axes. Here we're looking at depth, so how deep in the soil, and here we're looking at water content. Okay, so basically how much water is there depending on how deep you go. And they're asking, when were they closest? Okay, they're definitely far apart down here. Looks like they're pretty close right here, right? See how all of these lines kind of are close together around 30 centimeters deep. Let's see if that's an answer. Yep, 30 is an answer. F. 28 should be F. All right, which other ones ask about figure 3? 29 doesn't ask about figure 3. 30, no. 31, no. 32, I see figure 3. All right, let's look at this question. 32, which of the following statements describing how the average water content generally varied over the 140 centimeters of soil depth is consistent? So basically they're just saying which of these is true. Okay, but of course they ask it in a confusing way because it's the ACT. Which of these is true? All right, let's go through each of these. You will have to read them all. F, on each of the 4 dates, the dates are the different lines. You gotta pay attention to the key, right? All right, on each of the 4 dates, the average water content generally increased. Is it true that we went higher the deeper we went? That's not true for all of them because these ones went less water the deeper you went. These ones went more water the deeper you went. Okay, so it can't be F. All right, G. In each of the 4 dates, the average water content decreased. 2 of them decreased, but 2 of them increased. So it can't be G either. H. On October 26th and November 9th, so that'll be the 2 squares, the average water content increased with depth. So is it true for the squares that it increased? I see the squares going down. So it can't be that one. All right, J, last one. On October 26th and November 9th, the water generally decreased. Okay, so far so good. Whereas on October 23rd and December 7th, those will be the two circles, the average water content increased. Is it true the circles increased? Yep. All right, so our answer is J for number 32. That one required a lot of reading. Okay, let's see if we've got any more for figure 3. 34, yep, 34 is figure 3. All right, and you see how I'm writing all over the test? This test is on paper, it's your test. Make sure you write all over it, right? It helps you find information quickly, keep track of where you're at. All right, 34. Suppose that for a 10-gram sample of soil had been collected on November 23rd. So November 23rd, we are looking at the black circle line, at a depth of 60 centimeters. All right, so we're looking here, 60, black circle line. Based on figure 3, what mass of water most likely have been present? All right, so how much water is present in the black circle line at 60? Looks like about 20%. All right, we're gonna have to do some math. Let me switch to my pen. All right, so if 20% is present, that's a percent, on this date, they're asking for a gram. So this doesn't match any of my answer choices. I'm gonna have to do some math. We have a 10-gram sample. All right, so I gotta find what is 20% of 10 grams. To find 20% of 10 grams, you do 0.2 times 10, and that will give you 2 grams. So my answer for number 34 was G, 2 grams. That one took a little longer because there's some math. Usually you're not going to get more than one math problem per passage at most. All right, we will not go over the rest of these questions because they don't have to do with the line graphs. But again, if you want to find out the answer for those and why, there is an answer key document. All right, that's all I have for today. Thank you so much for watching, and we'll see you next time.